Hello, I'm Dr. Papia Bhattacharjee. In this problem, we have an equation of a line and a point given. We have to find two things. We have to find equation of another line that is parallel to this first line passing through this point, and the second part is we have to find equation of a line that is perpendicular to this given line and passing through this point. So, before we start solving, let me remind you of various forms of equations of a line. So, recall that there is a point slope form, which is if there is a given point, say x1, y1 on the line, and say the slope is m, then the equation is y minus y1 is equal to m times x minus x1. Second is the slope intercept form. In this form, suppose m is the slope and the y-intercept is 0, b, then the equation of the line is y is equal to mx plus b. So, we have two different forms for equation of a line. Now, let's go back to our problem. We have this line already given. In order to figure out a parallel line or perpendicular line, we have to first find the slope of this given line. So, let us rewrite this equation in the slope-intercept form first. So, x plus y is 7. Notice in the slope-intercept form, we only have y on one side. So, keep the y on one side and bring the x to the right hand side as negative x and then plus 7. Notice this is exactly like y equals mx plus b. So, we know that the slope is negative 1 and b is 7. Okay. This is already given. To distinguish between the three lines, because we will have equations of three different lines, let us call this one y1, because this is our first line. And let us also call the slope m1, because we will be dealing with two other slopes. Okay. Now, let's go to the first part of the problem. How to figure out equation of a parallel line to this line. So, two lines are parallel if they have same slope. So, if m2 is the slope of this line, then parallel will mean that m2 is equal to m1, and m1 is negative 1. So, we already know that this parallel line will have the same slope negative 1 as the first line. We also know that it will pass through the point negative 3, 2. So, we can use the point slope form and we say that x1 is negative 3 and y1 is 2, and use the point slope form to write down the equation. So, what is the equation? Y minus y1, which is 2, is equal to m1, or m2 is the same as m1. So, let's write m2 first, x minus x1, and just rewrite what our m2 is. So, y minus 2 is negative 1, and look here, it is x minus of minus 3, so it's x plus 3. Let's just simplify this equation a little bit. This is negative x, negative 3. Then bring the negative 2 on the right hand side. So you get negative x, negative 3 plus 2. And so we have y is equal to negative x, negative 1. So remember the first line, we said this is y1. This is our second line, so let's call this y2. So this is the equation of a line that is parallel to the first line and passing through that point. Okay, so to finish the problem, the last part, we have to find the equation of a line that is perpendicular to the first line and passing through that same point. So let's call M3 to be the slope of this line. Now what is the relationship between the two slopes of the two perpendicular lines? So perpendicular means that the product of the two slopes, so M1 and M3, the product is negative 1. Okay? And therefore, M3, that's the slope we want, is equal to negative 1 over M1. So now plug in the value for M1. So this is negative 1 over negative 1. So our M3 is 1. This is the slope. And remember, it's passing through the same point. So we again choose our x1 is negative 3 and y1 is 2. So let's write down the equation of this line. Again, we'll be using the point slope form. So y minus y1 is equal to, remember, now the slope is m3. So it's m3 times x minus of minus 3. So write down your m3 is 1. That's what we have. And here the negative distributes, so this is x plus 3. Simplify a little bit. Right hand side is just x plus 3. Then bring the 2 on the right hand side as y equals x plus 3 plus 2. So your equation is y equals x plus 5. And this is the third line, so let's call this y3. So we have equations of a line that is parallel to the given one and a line that is perpendicular to the given one passing through the same point. Finally, to finish this problem, we will check our result using a graphing utility. So pick whatever graphing utility you have. And how do we check? We have to, we can plot all three lines and see if they, like the first two are parallel and the first one and the third one are perpendicular to each other or not. And we have to have a square window. So why not set the window to, let's say, x minimum is negative 9 and x max is 9 and y minimum negative 2, and let's put maximum for y is 10. Let's go to y1 equals and plug in y1 is negative x plus 7. And then for y2, plug in negative x, negative 1. And then hold on for y3. Let's check those two first and then graph it. And look, the two lines are parallel to each other. Now go back to y equals again, and now for y3, keep the y1 and y2, and for y3, write down x plus 5. And then graph all three functions. And look, the third line is perpendicular to both line 1 and line 2. So using the graphing utility, we verified that we have correct equations. Thank you.